We'll start this lesson by transferring our files from around 18 to Prota structures. Come to Documents, you locate around 18. I have a lot of files here, but I'm more interested in training 1 and 2. Training 1, training 2. Copy. And locate Prota structure data 2016 and paste it here. Then we'll launch Prota structures. Okay, we'll locate training 2 and update it to Prota. Click OK. We'll update it and click OK. Select UK BS code, import. You wait. Okay, this is good. To offset houses on Prota structures is quite different from the way we did it on around 18. We'll start by clicking this offset houses. You hit F2 on your keyboard and insert the offset distance. Escape and escape. We'll do this again for the right hand side. Offset, give it a positive offset of 1000. Hit F2, 1000. Enter, escape and escape. And we'll repeat the same process for the ones in front. We'll click, right click, offset, take it downwards, F2 minus 600, escape and escape. Do it here also, right click, offset houses, minus 600, F2 minus 600. Okay, escape. The next thing we'll do is to rename the labels. Right click. Let's rename it to 1.0. Update and enclose. We'll move to the next one. Right click, properties. Update to 1.1. Update and close. And escape. We'll repeat the process for this. 9.1. Update and close. Escape. Right click. 9.0. Update and close. Then we'll update. Our next step will be to fix our columns, and we can't do that on the foundation level. We are currently on the foundation level. We'll take it to story 1. Okay, we'll click column. This is the label of the column we're about to draw, and the length theory is the number of floors with which this column is going to span, and these are the dimension for the column section and the eccentricity value. The B1 dimension is the dimension along the direction 1 axis, while the B2 dimension is along the direction 2 axis, same as the eccentricity values here. We'll start by giving it a value 450 and retain 250 here, and we'll place it here on the axis intersection, and we'll zoom in a bit. Okay, this is good. I want to move it a little bit to the left, so I will adjust set from here. Is 125 backwards and update. So that's cool. Repeat it here, place it here, and place it here. Next thing I would love to do is to slant these columns to grid 1.1. So I'll click this peak bottom is action point. I'll click it and I'll place it here for the last column and update. I'll deselect, take my mouse towards this next column and right click. Do the same process. Select insertion point, update. I'll escape, take my mouse to the next column, right click, select this insertion point, update, escape, select this, button, insertion point, and update. Then we'll repeat it for the right hand side. Place the column here. If you notice it's slightly out of place, we have to move it along a particular axis. Let's choose direction 1 and update. I want to shift the column towards the right by 125 forward and update. I'll place these columns here, place it here, and place it here. If you notice, the angle has changed to 40. Let's slant the columns like we did earlier. Update, escape, right click, select, insertion point, update, escape, right click, select, insertion point, update, escape, right click, select, insertion point, and update. Let's zoom out a bit. And to view the 3D view, let's close this. Come here, right click, 3D view. So this is what we have now. Let's take it back to the plan view and place all the columns. Come to column again, we'll select 250 this time around, and we'll set the eccentricity to center and place this column. Instead of dropping it one at a time, we can click and drag, 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 and click and drag. Okay, this is okay. We want to make a circular column at this intersection 1, 2, 3, and 4. We'll give it a diameter of 400. This value should be set to 0. And place 1 here. And yeah. If you want to create a circular column with a hollow at the middle, we'll change this value. We'll give it a negative value for the diameter of the hollow. We'll give it 150 minus 150 and click update. Zoom in to see what you've created. This is okay. That's the hollow. Zoom out a bit. Okay. This button is called the Coulomb End Condition option button, and it is used to release moments of the top, bottom, or both ends of the column, so it can assume pinned end conditions. So if we keep clicking this button, you can follow which end of the column becomes hinged. When one of the end of the column is hinged, the moments are released in two directions. That's the two orthogonal directions. We'll come to these other tabs. I can't explain this on this project. Let me switch to previous projects on my system so you understand this better. In a flat slab floor system, a drop panel is placed on top of a column to increase the punching resistance. We start by clicking the Start Column Drop panel and give it a value 900 by 900. Then we'll set it to center and we'll give it a depth of, let's say, 500 because the slab already has a depth of 300. Then we'll click Update, and this is the drop panel for the flat slab. Then we'll come to 3D. Let's change illustration. This is where we reset the plane definition. You can reset the plane definition at the top and the plane definition at the bottom. This structure has a slanting slab. It was created by plane definition here, and it has forced the columns which are linked to it to align to the plane definition. In case we want to detach this column from the plane definition, we'll reset top and update. Now it's completely detached from the plane definition. Then we'll repeat the same process for the column on top. Just a small column that has obeyed the plane definition, but we want to detach it from this level and bring it downwards. We'll escape, deselect. Then we'll select this little column and right click, properties, come to 3D and we'll reset plane definition at the bottom. Then we'll click Update. The column comes down, not obeying the plane definition again. And for this area, let's change illustration. In this feed, we can control the height of the selected column. We can control it from the top or from the bottom. We can increase the height 3000 upwards. That's it. We can actually still reduce it 1000. Downwards from the top. And that's it. That's reduced the height of the column. Let's take it back to the way it was before. And we can also do the same thing from the bottom and take it 1000 upwards. Update. Yeah, that's it. And we can actually still bring it downwards by a certain value, minus 2000, and update. Okay. And let's take it back to the way it was and update. If we want to change the properties of all the columns within this houses at once, we'll come back here and select this. We should start by increasing the size. And we click Update and select Other Stories and click OK. This will update the sizes of the column within the houses at once. Let's switch back to Training 2. To determine the support type at the bottom node of the column, we can adjust these values. If we set to default, the column bottom node will be restrained, but if we set it to none, the column bottom node will be free to displace. Let's take it back here. This is the section manager. This is the section name, the properties, We can edit the properties of the column here. And this is a material. You can change the material at any time. Maybe you want to use a different material for this column. You can change it. And when you're done, you just hit escape on your keyboard. The next step will be to create our wall. But first we'll have to remove these two columns so the wall can span from here to this and end here. So let's deselect. We'll hold down delete on our keyboard and click the column. Okay, that's okay. Then we'll come to wall properties. This is the label of the wall and the length theory, just the way we explained it in column properties. And this will be the thickness of the wall. We'll leave it at 250. The eccentricity 0, that means it's going to be aligned to the center. And these are the extension lengths. Extension length to the left and extension length to the right. Let me share an image. This is the extension length at the left and extension length at the right. It's actually good to leave it set to half the thickness of the wall. And close. So align to center. Then we'll pick this point. Pick another one. Drop it here. Pick it again and drop it here. And this will be our shear wall. If we choose to slant this wall, we'll come to the bottom section axis. We'll pick it. We'll select the axis we want this wall to slant to. But I'm not going to do this here. So I'll select this. I'll move to drop panel tab. And the drop panel tab is just the same way I explained it in the column. We'll come to the 3D tab. All this will be similar. And for the support type, as I said earlier, if it is default, is going to be fixed and restrained is 6 degrees of freedom, while for none is going to be free to move at the bottom. We'll come to the wall model type. The wall model type, we have options here. We can use the mid-pair model or the finite element shear model. Okay, let me show you this. The mid-pair model utilizes a column at the center of the wall with 2 rigid arms, which extends to the 2 sides of the wall at the top and also at the bottom. The finite shear model is used for more accurate results. Let's close this. But we leave it as default. If you don't understand any of these two models, it's safe you just leave it as default for now. Then we'll close. Next thing we do is to create the beams in the structure. So I'll zoom out to leader. This will be okay. You click beam. This is the label of the beam and the beam type. If you set to normal, they are just regular beams. And the support band beam, they are used only when finite element floor models are created for flat slab systems, where there are no physical beams between the column and the wall. And this fictitious beam is used to mark out the support regions in flat slab systems. We come to the section manager, see the information about the beam, the properties we can edit, the material we can change, and when we are done, we escape. This is the width of the beam. I'll leave it at 250, and the eccentricity and the depth of the beam set to 500, and this is the height of the beam above the slab, and we'll set it to align to the middle, and this is used to release the moment at both ends or one end of the beam by just clicking so that it can assume a pinned end condition. And this is used to change the properties of all beams on the same axis in every floor, just as I explained it using the column. Let's start creating our beams. To create continuous beam, you don't take it one at a time, like from 1 to 2, from 2 to 3. You have to take it from the very start point to the end. If we take it one at a time, Orion will treat it as separate beams. So we'll continue and lay it here. We'll escape to start another selection. We'll click stop it here. Start another one. Stop it here. Start another one. Stop it here. Escape. 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 And escape. So I've fixed all the horizontal beams. To make a circular beam, you can use this method. You can click this insertion method, pick this point, and pick these other points and the center to fix a circular beam. Or let's escape, undo. You can just hold shift on our keyboard, click and click. It's a very fast method. The next thing we do is to create our vertical beams. Escape. This beam to this end. Escape. This beam comes out of the building, stops here. Escape. This beam also. Escape. This beam also. Escape. This beam. Okay, this is good. Let's move to the 3D tab. Okay, I'll have to explain this with another project. Let me switch. This beam is slanting upwards according to the plane definition, and at the eye region it's raised 533.07 mm. I want to raise this beam a little bit higher, but first I have to detach it from the plane definition. Then we'll click here to reset it at that point and update. Then I can change the value to what I want, at 2000, and update. It has raised the beam higher at that point. Let's take it back to the way it was. And 07, and update. With this method, we can slant any beam in the building. Let's close this and escape. Then select this beam, properties, come to 3D. I can raise the eye region by any value. So basically, this is used to slant beams in a building. Let's switch it back to our training 2. The next thing we'll do is to create the slabs on the structure. But before we do that, we'll make the additional loads that will be acting on the slab. Let's close this and we'll click member, slab additional loads library. We'll create a new load, give it a name. Let's call it office. Then we'll add materials. Let's start with concrete. Give it a thickness of, let's say, 50. Add another material. We use cement mortar. Give it a thickness of, let's say, 10. No, that's too small. Let's make it another 50. Then we'll insert the other material, mosaic tile, and give it a thickness of 10. And when we are done, we'll click OK. If we want to make other materials or add materials to the material library, we'll click Edit Material, then add a new material. But we don't need to do this now. Just close and click OK. The next thing will be to insert our slabs, slab properties. And this is the label of the slab, the type of slab. Let's click from 1 to 13, and for the one with spanning slab, we won't adjust this value because the software automatically decides the type of slab. We'll change this value to 150, give it a cover of 25, it's okay. And we'll go to load. The self weight is calculated automatically depending on the thickness of the slab. And this is for the additional loads. We can give a value, let's say 2.500, or we can select from our additional load library. Let's click Office. And for the imposed load, we can just type the value that we want, or we'll right click and select the one we want. I think let's select offices. Let's find offices, and this is it. For the reference level is just the reference to the slab top. We can give it a negative or positive value, and let's leave that for now. Slabs are considered to behave infinitely rigid in their planes, thus forming a rigid diaphragm action. If we check this, the slab will no longer participate in rigid diaphragm action. Hence, all the nodes at the corners of the slab will displace independent of the rigid diaphragm. Well, I don't need this, just click it. And I'll start placing my slabs. 1, 2, 3, 4, 5, 6. Okay. I've left this for the rib slab and the waffle slab. To delete any of these slabs, I can just escape, select the slab I want to remove and delete. Okay. And the next thing will be to create our rib slab and waffle slab. Select rib slab, and we have the label and the type. The type, we have the standard type, and this rib slab is a monolithic rib slab that spans in one direction and it is fixed to the beams, while the prefabricated slab is also spanning in one direction but hinged to the beams. Well, the grillage is used to make waffle slabs spanning in two directions. We'll click standard. We give the rib a width of 120 and retain other properties, and this is the depth of the rib beam, thickness of the slab, leave it at, let's say, 100, and the size of the block, leave it at 450. Then we'll skip to the loads tab. We know the self weight is calculated automatically. The additional load, we select office, and for the imposed load, you click, right click, select office. And the parapet load, this is a dead load added to cantilevers. Then we'll place our rib slabs. Let's select this, and select this. We want to change the angle of these ribs. Come to insertion and give it an angle of 40. And click update. And this is okay. Next will be to create our waffle slabs. Come here, select grillage, click this and click this. Then we'll close this, create our cantilever slabs this time around. Select 12 type and give our slab a thickness of 150. We'll leave this for now. and give the cantilever a length of 600. We come to loads, select office and post load, and let's use office general use. Variable load, let's just use 1, and place our cantilever. Cantilevers are placed in anti-clockwise direction, so we start by clicking from column to column. 1, 2, 1, 2, 1, 2, 1, 2, and let's close this. Deselect, start it again, the same process. 12, 150, loads, office, 1, and then give it a length of 1200 this time around. I'll pick it from here to this, so it's going in anti-clockwise direction, and from here to here, and from here to here. The next step will be to make our curved cantilevers. We'll have to close this first and deselect. Let's select on these 2 cantilevers and delete them so we can place our curved cantilevers. Okay, then we'll come here, you click on slab stroke column edge, pick on this point, pick on this one, and let's give it a value of 1200. We'll start by hitting F2 and give it a value 1200. We will come here again, select slab stroke column edge arc, pick this intersection and this intersection, and give it 1200. Enter. Then we'll come to slab, select any of the types here, but not the 12, 13 and the one we fabricated slab. Let's select this for now, and we'll give it a thickness 150 is okay, and the load, we'll cross check the load, it's okay, and we'll place our slabs 1 and 2. When we're done, we can close this. You can change the position of the label on the slab. Just right click any slab and come to label. You can bring it to the left upper corner. The update, bring the label here. That will be all. Let's just take it back to the center. The next step will be to set the slab types automatically. So come here, right click, set slab types automatically. Then we'll click OK. It has set the slab type automatically. We'll click OK. The next step will be to add additional loads on the beam and on the slab. We'll start with the wall load for the beam. And before we do that, we'll have to come to the wall library, wall types library, and we'll create a new block. We'll call it 225 block wall Nigeria. Can give it another color. Let's say this is okay. And we'll add materials. Let's select. I don't want to use any of this. Let's make our own material. I'll start by adding and give it a name. Our block, and assume a unit weight of 12.0 756. Okay, this can only take 2 decimal places. Let's say 76. And click OK and select material. Pick our block. Let's say 225. And now add another material. Let's take plaster and give it the thickness of 13. Then click OK. I'll come to my beam and right click, beam wall load. I can insert the value for my dead load, or I'll just come to the block wall I created and give it a height of 3 meters. I won't consider the openings for now. I just click OK. This is good. Then we'll copy the wall load from this beam to other beams along the boundary of the building. First we have to remove this grid because it's going to disturb us when we are clicking the beams. And we'll come to the layer toolbar, we'll deactivate the grid. Okay, it's okay. We right click our beam, copy beam wall load, and select the beams. Then we'll right click and paste copied beam loads, and that's okay. You can delete the beam wall loads. All you need to do is select the beams you want to remove the wall load. You right click, delete beam wall load, and yes. The next step will be to add manual loads to the beam, and let's deselect. We'll pick on any beam just to illustrate. Right click, you come to edit member load, and this is the load transfer side. It indicates the direction of load acting on the beam. You come to load, it could be a self-weight, wall load, or uniformly distributed. And D is the distance from the high end of the beam to where the load is acting. And member will provide the info about the member that is transferring load to the beam. As you can see, this is the slab transferring load to this beam. And we'll come to new load. Let's start with point load. We'll give it a value from the high section of the beam. Let's give it 2 meters. Let's give it value for dead load and value for live load. If you want to use a UDL, you can add a UDL. We'll click OK. Now it has added our load. And we'll come to new load again, just to give it a UDL. Click this and give it a dead load of, let's say, 10, and live load 10, and click OK. Okay, it will be okay for now. And this means that the load are manually created. And you can delete them if you want. Select, delete if you want. If we pick on any load, it will be indicated by the red color. This is self weight. And this is the wall load, additional load, and for slab load. Okay, we're not going to make any adjustments here, so all we'll do, we just click OK. Okay, the next thing we do is to apply loads on our slab. Let's come to slab load properties. We'll start with the point load. Let's just give it a value for illustration. This is for the dead load. Then click up for live load. We'll give it another value. Let's say 10. Then we'll start by picking our reference point. We'll click here. Then we can decide where our point load is going to be. Let's place it somewhere around here. You can specify the exact position by hitting F2 on your keyboard, and you give it the length, distance, let's say 3000, and you give it the angle, let's say 45. When you're done, just hit enter. So the point load is placed on that point. So let's move to line load. You see the values for the live and dead load, live load. Okay, we can change these values, and let's start by placing our line load. You can click any point and drag the line. Okay, we'll click OK. So this is going to be our line load. The next load we are going to illustrate is the area load. Check the dead load and the live load. That's okay. 20 and 10. We'll pick a reference point. Let's pick our reference from here, and we'll draw a rectangle for the area. Let's place it here. It's okay. And we'll click update to show the length and breadth of the area load is acting on. So this will be okay for now. Let's close this. The next thing we'll do is to add more storage to this structure. And scroll up, select storage, right click, insert storage. I want it to be a 7-story building. I'll click OK. Nothing is displayed. Well, let me bring back my as-is. Okay. Then we go back to story 1. Click stories, right click, generate story. Copy information from story 1 to story 2. Click story 2 and OK. Then close. You see, story 2 now has a unique layout, and that's what you're looking at. This is currently story 2, and this is story 1, and this is story 2. We want to make some modifications, so I don't want the story 2 to have the slanting columns. So I'll click on a column. Let's click on this one first. Right click, properties. Then we'll come to pick bottom insertion points and specify this again, taking it back to its former look. I'll click update, close, escape, right click, bottom insertion point, right click, update, close, right click, Let's zoom out a bit. Okay, it's good. And zoom into this region. I want to place columns on these cantilevering beams. So I'll come to column, 250 by 250, set to center. I'll place it on this beam, on this beam, on this beam. Place it here too. Place it here. And yeah. So the beam will be holding the column at the other end of the cantilever. Let's close this. The next step will be to transfer information from story 2 down to story 5. I'll click stories, right click, generate story, select story 3, 4, 5, and click OK. Yes. And I'll close. This will take me to story 5. I want to delete some columns and beams on this story 5. First, I'll hide my axis lines and create a window to delete the elements I want to remove. I'll right click and click delete. And I'll delete this cantilever. Click OK. Let's delete this also. Okay. I'll ignore this error and click OK. Leave it just like this. I mistakenly deleted this column. I'll have to bring it back. Activate my axis. Click column and place it here. Okay. And let's deactivate axis again. The next step will be to transfer this layout to story 6. So I'll come to generate story, transfer it to story 6 and click OK. Okay. And close. And I'll make adjustments to story 6 again to delete this area. Right click and delete. Okay. Select, delete, select, and hit delete. Okay. And pan upwards, select, delete, and I'll zoom to extent. And I'll pick on these elements and delete them. Okay. I'll copy information from story 6 and send it to story 7. Right click, generate story to story 7 and click OK. Yes. And close. And I'll delete the things I want to remove in story 7 too. Right click, delete, or just hit delete on my keyboard. I want to remove the waffle slab. We'll start this lesson by transferring our files from around 18 to Prota structures. Come to Documents, you locate around 18. I have a lot of files here, but I'm more interested in 21 and 2. 21, 22. Copy and locate Prota structure data 2016 and paste it here. Then we'll launch Prota structures. Okay, we'll locate training 2 and update it to Prota. Click OK. We'll update it and click OK. Select UK BS code, import. You wait. Okay, this is good. To offset houses on Prota structures is quite different from the way we did it on around 18. We'll start by clicking this offset houses. You hit F2 on your keyboard and start the offset distance. Escape and escape. We'll do this again for the right hand side. Offset, give it a positive offset of 1000. Hit F2, 1000. Enter, escape and escape. And we'll repeat the same process for the ones in front. We'll click, right click, offset, take it downwards, F2 minus 600, escape and escape. Do it here also, right click, offset houses, minus 600, F2 minus 600. Okay, escape. The next thing we'll do is to rename the labels. We'll right click. Let's rename it to 1.0. Update and enclose. We'll move to the next one. Right click, properties. Update to 1.1. Update and close. And escape. We'll repeat the process for this. 9.1. Update and close. Escape. Right click. 9.0. Update and close. Then we'll update. Next step will be to fix our columns, and we can't do that on the foundation level. We are currently on the foundation level. We'll take